Okay, this is dealing with the integumentary system, which is the skin. You notice here we do have a cross section of it and the different layers of it. On the very surface is the epidermis. That's what this layer from here to here is. And then we can separate this. So this that I've just moved back, it's the epidermis layer, and then when you go deep to that, you have the dermal layer, which itself is divided into two layers, which the division would be roughly about here. And then underneath it, it's not technically part of the integumentary. It is, some books will call it your subcutaneous, others your hypodermal layer. It has a lot of adipose or fat tissue in it. Years ago, they used to include it as part of the integumentary system. Now, technically, they take it off, but it doesn't really belong anywhere else, so they still throw it in for you to study with the integumentary system. So it's going to be deep to the dermal layer. If we start on the surface with the epidermal layer, we can distinguish between either 4 or 5 layers. Most of the body has 4 layers, but the palms of your hand and the soles of your feet have an additional layer because you have so much abuse and pressure that's placed upon it, so it's for extra protection. The cells that are actively dividing are down here in the deepest layer, and as they go through mitosis and divide, they produce 2 daughter cells. One stays, and the other daughter cell gets pushed up. And there are different structural changes that will occur, and by the time you get up here to the outermost layer, the cells are dead. So I'm sorry, but most of what you see in each other is dead. So this is the outermost layer. There are different proteins in here that do help prevent bacteria, viruses, fungi, anything, foreign substances from being able to penetrate deep in. And it also helps to keep you hydrated, keeps you from losing water. In the dermal layer, which is beneath it, you can see here that you have blood vessels that are throughout this layer. They extend up, and notice it's not even, but it has these ridges, the little papilla here. And notice that you have the blood vessels that will extend up here. But notice the blood vessels are not in the epidermis layer. That is one major difference. As I said, the cells right down here are living and going through mitosis, but as you move further away, they die. One reason is they're further away from the blood supply. They cannot get oxygen, they cannot get the nutrients, and so they'll start to die off. Just kind of interesting side note, when you say get a paper cut, just a small cut, and number one, you're going to feel it, but notice sometimes when you get a paper cut, it doesn't bleed. Have you ever wondered why? If you only cut into the epidermis, there's no blood supply. So if you cut yourself, you're not going to bleed. But there are nerves that extend here, so you're going to feel it. Now, if it bleeds, then that means you cut deeper and you're into the dermal layer. So that's just kind of an interesting side note. So what else do we have in the dermal layer here? This white structure right here. This is a sweat gland. Notice that the gland is down here deeper, and you do have this separate duct that goes, and if we put this back together, it's a little bit easier to see, that it does extend to an opening on the skin, so you have your sweat pore here. Over here, you have what's known as a sebaceous or oil gland. It does not have its own separate ductwork like the sweat gland does. Instead, the sebaceous or oil gland, on this cross section you can see here, it's going to surround and be attached to a hair follicle, and the oils will be secreted into the hair follicle and then can move up with the hair. Technically, what you see above the surface of the skin is referred to as the hair shaft, and then below here is the hair follicle. Down here at the very bottom is the hair root in this bulb area, and this is where the cells for the hair are actively growing, very similar to what you see in the epidermis. The cells go through mitosis, producing 2 daughter cells. One stays and the other one gets pushed up. As you can see right here where the cells are actively going through that cell division, you do have a good blood supply coming in. But as the cells get pushed further and further up the hair follicle, out to the surface, what you see once again, these cells are also dead. So once again, what you are seeing is dead. Excuse me. There are other structures embedded that allow you to feel pain, different sensations such as temperature. They're very specific, whether it's being able to feel deeper pressure or maybe just very light touch sensations, like you could feel if there's a spider crawling across your arm. Right here, this is a muscle called the erector pili muscle. Notice that it is attached to the hair follicle. When this muscle contracts, it is going to take this hair follicle and it's going to stand straight up. And that's when you have goosebumps. What's the purpose of having goosebumps? It's something that's left over. It's often you're triggered when you're cold to get goosebumps, but also when you're scared. And what that does, if any of you have cats, it's very similar to what you may see in your cat when your cat is startled, is that it seems like it fluffs up. The hair, when it stands on end, it makes you look bigger. And so the idea is maybe you can scare off whatever it is that's scaring you, because suddenly you look bigger. So remember, you've got the epidermis, you've got the dermal layer, beneath that is the hypodermis or subcutaneous layer. Embedded in the dermal layer, you've got your hair follicles, the erector pili, you've got your sebaceous glands, your sweat glands, you have numerous amounts of blood supply and nerves that are embedded within the layer. Some of the nerves do extend into the epidermal layer. And like I say, the whole purpose of the integumentary system, there's several purposes, but one big one is for protection. It's a barrier, it's a physical barrier keeping outside things out. It's also going to be involved with things like starting the process for making vitamin D. It prevents you from getting dehydrated, and so several different things like that.